Welcome back to the series on statistics. It's going to be a quick little video. We're going to do a little bit more of a detailed discussion about these probability density functions. We talked about what they were in the last video, the introduction to continuous distributions, but in this video, we're just going to handle this common question in statistics courses, which is asking whether or not a PDF is valid. This shouldn't be very long, but I feel like it's necessary to cover because you're always going to see these types of questions in any statistics course. So without further ado, let's get through this. So with our first example here, we're asked, is f of x is equal to x squared plus 16x minus 1 a valid probability density function for x on the interval from 0 to 2? These questions aren't usually asked like this. Typically, you'll have some type of situation. So it'll be like the probability that a unstable particle will emit some alpha particle is given by this function. Is this a valid probability density function on this interval? It'd be something like that, but I kind of cut off the fat here for this video. When we're asked if these probability density functions are valid, what we're asking is, from the last video, we laid out that there were certain assumptions associated with these probability density functions. There's an implicit third assumption, which is that this probability density function, the area underneath it, over some range of values corresponds to the outcome of your statistical experiment falling in that range of values. That's usually given in the form of the question. So they'll say, this is modeled, the probability of this outcome is modeled by this function. That's a given for most of these questions. But we have to check these additional two assumptions, which says that if you integrate over the probability density function for all the values in the support, you have to get 1. This is effectively saying if you sum up all the probabilities of all the possible outcomes, you have to get 100%. So it's pretty self-explanatory. Then the second assumption here is that the probability density function needs to be positive for all values of x in the support. Now, in the last video, I kind of hand-wavingly said that this meant that you can't have negative probabilities, of course, and so that's why this assumption is in place. I want to be a bit more clear because you might have realized that the probability density function is not giving you a probability. It's the area underneath this function that's giving you the probability. But I want to make the point that these functions have to be continuous. Otherwise, we wouldn't be able to integrate and get the area underneath them. And so if we're dealing with a continuous function and there's at least one negative value in the support, then it can't get from a negative to a positive without jumping, and it can't jump if it's continuous. So if this is a continuous function, then that means there has to exist at least one other negative value, technically infinitely many, but if there's one negative value in the interval of the support, then there has to exist at least one other negative value, and thus there must be an interval in which all values are negative. And if you took the area underneath that function over that interval, you would have to get a negative value. So there would exist some negative probability in the support if there was at least one value for which the probability density function was negative in the support. I just wanted to clear that up. That is why that assumption is in place. So with that said, we know immediately that this function is not valid because we have this minus 1 here. And since we're dealing with the interval from 0 to 2, if you were to plug in 0 here, you would get 0 plus 0 minus 1, and you would have a negative value in this support. So this is not a valid PDF. This is invalid. And we actually don't need to keep going. But I do want to make the point that it's important to check both assumptions, because if you go through this checklist here, and you don't immediately recognize that, and you go for the first one, and you were to integrate this function, let's see, x squared plus 1/6 x, that's a horrible 6, minus 1 from 0 to 2. I purposely chose from 0 to 2 so that we don't have to evaluate this twice, but this is just going to be x cubed over 3 plus 1/12 x squared minus x, evaluated at 0 to 2. And as you might have guessed, I probably conveniently chose this such that we're going to get, 4/12, that's the same as 1/3, minus 2. This is going to be 3 minus 2, which is 1. And so it does meet this assumption. So you have to check both. You have to remember that you can't have a negative value for the x in the support. Sometimes it's not going to be this obvious, as in this case. You'll deal with the interval of positive values or some eclectic values, and you won't have an obvious negative constant. So usually you're going to have a calculator, so it's just easier to graph the situation and make sure it doesn't go beneath that x-axis. So this is an invalid PDF. Now let's take a look at our second example here. I have a graph here. This is a graph of our probability density function for this example. So it meets the first assumption. The PDF is going to be greater than 0 for all x, the interval 0 to 2. And so that's our first assumption, or second assumption. The order is not really important, but we still need to check that the area underneath this probability density function over the support has to be equal to 1. And so let's do that. Go from 0 to 2 of negative 3/8 x squared plus 1/2 x plus 1/2 respect to x. Now, once again, you're generally allowed to use a calculator in these statistics classes. So if you prefer to just plug this into your calculator, you can. But this is a simple polynomial, so let's just do it. We get negative 3 over 24 x cubed plus 1/4 x squared plus 1/2 x evaluated from 0 to 2. And so what is this going to give us? It's going to give us 8 times negative 3, just negative 24 over 24, that's negative 1. And we have 2 times 2 is 4 over 4, that's going to be 1, plus 1. And we have plus 1/2 of 2, that's just plus 1. So these will cancel, and be left with 1. So our second assumption is met, and so it meets both of our assumptions, and this is a valid PDF. Valid PDF. All right, so that's how you negotiate these problems. I hope you all enjoyed. Next video in the series is going to cover the normal distribution. That's definitely the most exciting thing that's going to come out of this course. So keep an eye out for that. There's lots of applications for the normal distributions in real life. Thank you all for watching. See you guys in the next one.